topic, that is entropy. Entropy, in simple words, if you want to define the entropy, let me give you one example. Let's suppose you people are present at your home, or at your home you are present in your room. So if you are present in your room, okay, so you are reading different books, notes. So what would happen to your room? Everything that is scattered, it is in disordered form. Okay, they are not present at their proper place. Okay, so they are disorderly arrangement. If you are present in the room, okay, when you come to the academy or school, what would happen? Your mom, she goes into the room, or say the maid that please put these things in the order, put books in the shelves, put your pillow at its proper place. Okay, so she is going to put everything in order form. Okay, so your room, that will become order. So entropy is basically the disorder in a system. Okay, so if a system moves from the orderly arrangement to the disorderly arrangement, so its entropy, that is going to increase. And if a system moves from the disorderly arrangement to the orderly arrangement, its entropy, that would decrease. Did you get it? Okay. So first of all, you should write the definition of the entropy. What is the definition of it? The disorder in a system is called entropy. So this is the first thing. Okay, its definition. The second thing, if a system moves from orderly arrangement to disorderly arrangement, its entropy increases. The next thing, if a system moves from disorderly arrangement to orderly arrangement, its entropy decreases. Okay, if the entropy increases, it means it got the positive value, and if the entropy decreases, it got the negative value. So we have done up till now the three things. First is the definition. If the system moves from the disorder in a system, that is basically the entropy. And if a system moves from the orderly arrangement to the disorderly arrangement, its entropy, that would increase, having the positive value. And if the system moves from the disorderly arrangement towards the orderly arrangement, its entropy, that would decrease, and it is having the negative value. Did you get it, my dear? Okay. The next thing, entropy is represented by the symbol S. So if you want to write down the entropy is denoted by the symbol S, and we put the fire sign on it. I told you many times, this fire sign, that shows the standard conditions. Standard conditions. And standard conditions, there are three. The first one, 25 degrees Celsius room temperature. The second thing, 1 atm pressure. And the third thing, the reactants, they are in its more stable state. Okay, carbon exists in solid state. So carbon should be present in solid state, not in gaseous state. Yeah. वही वो 25 to 98 कैलोरी कर लो उसको एक ही बात है कोई फर्क नहीं पड़ता so 1 atm or the third thing the stable state reactants so these three conditions they are required okay for the enthalpy change as well as for the entropy okay so entropy is represented by the symbol as 5 written on it. And if the word entropy change, so that is delta S and phi. Okay. The next thing, its units. Its units are to joule per Kelvin per mole. Okay. The next units they are kilojoule per Kelvin per mole. Okay, so these two are the units. So mostly in your questions they provide you these units. Okay, but before doing the calculation you have to change them into kilojoule per mole per Kelvin per mole. Okay. So these units you have to use. So most of the time he gives you the calculation. He gives you the values in that. Okay. So don't use these values to find out the entropy change, but after that you should change them into kilojoule per mole before your future practice. Okay. So we will do those questions as well. Don't you worry about it. Okay, my dear students. Now I'm going to take the example. Let's suppose if I got the solid. If the solid changed into liquid. Any one of you could tell me what happened to the entropy? Yes. If a solid changes into the liquid, okay. So solid say liquid, entropy increase. Why? Because in the solid the particles they are closely packed together like that. Whereas in the liquids the particles they are present in the clustered form and they are having the spaces. Okay. So I'm going to repeat this whole thing one more time for you. First thing, the disorder in a system is entropy. The second thing, if a system moves from the orderly to disorderly arrangement, entropy increases. So if you see solid to liquid, this is the ordered arrangement. This is disorderly arrangement. Okay, so entropy increases. So entropy increases. Okay, and having the positive value. Okay, and from liquid to gas, liquid to gas increases. So entropy again increases. Yani F increases, having the positive value again. Okay, so if I am going to here in the gases, the particles they are very furthest apart from each other. They are bonders, they are moving here and there haphazardly. Okay, now if the gas changes into the liquid, decrease. So entropy decreases, having the negative value. And if the liquid changes into solid, the entropy decreases again, having the negative value. Did you get it? Yes. We are going to have a look. I'm going to make the equations for you, and all of us, we are discussing whether the entropy of this equation increases or decreases with reason, not a tuka like that. You don't say, oh, I just guessed it. No, you have to tell me the reason. Okay, I'm going to write down the first example, that is Mg. Okay, then HCl is going to form MgCl2 and then hydrogen. Okay, so any one of you could tell me with the reason whether the entropy of this system increases or decreases. Come on. Yes, yeah, बोलो.
Sir, increases.
Increases. Very good. तुमने क्या कहा? Increases बढ़ता. अच्छा, अब रीजन सुन लें. What is the reason behind it? Force increase करती है entropy. लेकिन रीजन भी तो हमें पता होना चाहिए ना. If we look, this magnesium is a solid. HCl, that is aqueous means it's a liquid thing. So MgCl2, that is aqueous, that is also the liquid thing. So liquid are present on both sides, so just ignore it. This is solid, and hydrogen, that is a gas. So solid to gas, my dear, the system moves from the orderly arrangement to disorderly arrangement. So of course the entropy increases and having the positive value. Okay, so you should write up here the entropy of above equation increases and having positive value as system moves from solid to gas. Okay, so this is the first example of it. Okay, now let me give you one more example. I got H2O and I got H2O liquid form. So anyone, this is basically steam. It's a steam, and it is changing into water. So entropy that would decreases. Why? Because in the gaseous form, the particles, they are more disorderly arranged. Whereas in the liquid water, the particles, they would become little bit more arranged. Okay, so the entropy of this system that would decrease. Okay, the entropy of this equation decreases and have negative value as system moves from gas to liquid. Okay, guys. Now I'm going to write down an equation up here, and it's a challenging question for the students physically present up here and online students. So let's see who is going to give the answer correctly with a reason. Okay, so let's check you people. The third one. So nitrogen. Then we got.
सर ये मुझे
जी
सर ये पहला और दूसरा एक दफा फिर बता देंगे.
बेटा यहाँ पे देखो, ये सॉलिड है, एस का मतलब सॉलिड है, ये
जी
गैस,
सर.
ये एक्वस तो सेम है, इनको भूल जाओ. सिस्टम सॉलिड से गैस की तरफ जा रहा है, तो सॉलिड से गैस भाई डिसऑर्डरली अरेंजमेंट होती है, बढ़ती है, तो इसीलिए एंट्रोपी हमारी इंक्रीज कर रही है, पॉजिटिव वैल्यू है. यहाँ पे गैस से लिक्विड की तरफ आ रहा है, तो गैस से लिक्विड पार्टिकल ज्यादा अरेंज
डिक्रीज हो.
डिक्रीज होती है. ठीक है
जी सर, समझ गया. थैंक यू सर.
बड़ी मेहरबानी. ओके गाइस, so this is the equation, and any one of you could tell me what happens to the entropy of this system with answer. No change. Very good. And what do people think? Come on, online students, I want your suggestions as well. Even if they are wrong or correct, doesn't matter. So just try for it. Yeah, Fatma, we should start it up. What do you think about it?
There's no change because there's no change in matter.
Okay, that's fine. What about you, Maria?
No change, sir.
Sir, no change.
No change. Okay, guys. So I think most of my students, they are saying no change. So you people are not correct. One student says it decreases. He is correct. What is the reason behind it? I'm going to give you one example. Let's suppose this is my room. Just listen. This is my room. In this room, if I got the 10 people and if I got the 100 people, if the 10 people are present, they are more away from each other. Disorderly arrangement. Whereas the 100 people, they are closely packed together, my dear. So if you look up there, sorry, the more number of moles of gases mean more number of particles. So 3 and 1, 4, 4 moles of gases. Here we got 2 moles of gases. So less number of moles of gases mean that there is less disorderly arrangement. Okay, so here more particles mean more disorderly arrangement. Less particles mean less disorderly arrangement. Okay, I think पहले मैंने कुछ गलत कह दिया मुझे लग रहा है यही कहा था पहले भी I have told you the same things before. अच्छा तो अगर आपके पास both sides contain the gases, okay, here gases are present, here gases are present, then you should count the number of moles. Less number of moles mean less number of particles, less number of particles mean more orderly arrangement. Okay, so here disorderly arrangement. So the system moves. So this is entropy decreases, having the negative value as system moves from more number of moles of gases to less number of moles of gases. Okay? Everyone got it, beta?
Yes, sir.
So please remember, my dear students, if you got the same physical state on both sides, then you should count the number of moles. If more number of moles of gases are present, so more disorder arrangement. Less number of moles of gases, it's orderly arrangement. Okay, guys. Now the last thing about the let's suppose we got Mg plus Cl. Sorry, Mg plus Cl2 is going to form MgCl2. This is solid, gas, and this is aqueous. Not aqueous. This is solid as well. Okay. So first of all, what do you think about the entropy? So here solid is present, here solid is present as well. But here gas is present, here no gas is present. It means that gas changes into the solid as well. So it means the entropy that would decrease, having the that. Okay. Now I'm just doing the calculation. In most of the papers, what they do, they provide you the entropy of every species. Like he's going to provide you the entropy, not entropy. Entropy of Mg, let's suppose it's plus 23.4, Cl2 that is minus 47.9, MgCl2 that is positive 60. Okay, so these entropies are given and their units are joule per Kelvin per mole. Okay, so now what you are supposed to do, my dear students, you should find out the entropy change. If I'm going to ask you find out the entropy change delta H, you have to find out. Now, please remember, yesterday I told you in the formation values you should use the rule EPR. So entropy में भी आपने EPR use करनी, E for entropy. So EPR rule इसमें भी use होता है. एक formation की values और एक ये entropy की values. So EPR का मतलब E for entropy change है this time. That is equal to P for products, okay, and minus reactants. Okay. Now products. This is the product. So this one is plus 60. Let's suppose if 2 is written up here. I'm going to suppose it. So you should multiply it with 2. I'm just going to suppose it. Okay, but here nothing is written, so it means it's single. So the product that is finished. Now you should subtract it with the reactants. So Mg, that is plus 23.4 and plus minus 47.9. If you solve it up, you will get the answer in joule per Kelvin per mole. So that would be the entropy change. Did you get it? Yes. Because all of you have to appear for the test tomorrow. Okay? कल जो है ना टेस्ट के लिए एग्जैक्टली कोशिश करना, थोड़ी सी पास पेपर प्रैक्टिस कर लेना, जितना होगा डजंट मैटर, दे देना, कोई फर्क नहीं पड़ता। बाद में उस टेस्ट को मैं जब यहाँ पे डिस्कस करूंगा तो यू विल गेट एवरीथिंग। ओके ओके गाइस, now we are going to start with the Gibbs free energy. This is the last thing. Gibbs free energy. Gibbs free energy, that is denoted by the symbol delta G at the 5 prime unit. Gibbs free energy. Okay. Let's suppose, my dear, I'm going to write down an equation up here. Mg plus HCl, that is going to form MgCl2 plus H2. Okay. The enthalpy change of this reaction is negative 40 kilojoule per mole, whatever. Now, whatever the thing I'm saying to you, just listen it, because this topic is little bit hard. But for your convenience, to make it easy for you, I'm going to use very simple words in a simple manner. What is the Gibbs free energy? Okay, this is the equation. The enthalpy change of this reaction is negative 40 kilojoule per mole. It means negative 40 kilojoule energy is released in this reaction. Did you get it? Okay. Now, this negative 40 kilojoule energy does not reach us. Okay, all of the value of negative 40, that is not usable. That does not come to us. It's not workable. Why? Because some part of this energy released, that is going to increase the temperature of the system. And the second thing, some part of this energy is going to change the entropy of a system. Let's suppose if a thing is liquid, it would change into gas. I'm going to give you one example. You people have gas cylinders or free gas coming at your home. You know that. What is that? It's methane. So methane CH4. So when it burns, it forms carbon dioxide and water. So water, that is a liquid. But when you burn it, you do not see any water droplets up there. But if you put your hand up, you will feel the droplets attaching up here. So basically, the heat energy total produced by the burning of methane that does not reaches to us, some part of that energy is used to increase the temperature of the system, and some part of that energy is going to increase the entropy of the system. And after subtracting these two things, whatever the workable energy that reaches to us, let's suppose maybe it should be negative 25, maybe it should be negative 23, maybe it should be negative 30, maybe it should be negative 35. I'm just going to suppose. Okay, so whatever the workable energy that reaches to us after increasing the temperature and increasing the entropy of the system, so that is called as Gibbs free energy. मैंने बहुत सिंपल तरीके से बताया है कि कोई भी जो रिएक्शन है, इसमें जो टोटल एनर्जी है, हीट एनर्जी, वो सारी की सारी हमारे काम की नहीं होती, सारी हमारे तक नहीं पहुंचती। कुछ उसका पार्ट टेम्परेचर इंक्रीज करता है और कुछ उसका पार्ट what does it do? It is going to increase the entropy of system. तो उसके बाद जो वर्केबल एनर्जी हम तक पहुंचती है, that is my dear Gibbs free energy. Okay, so Gibbs free energy का ये फॉर्मूला तुम लोगों ने याद रखना है, डेल्टा G is equal to delta H. डेल्टा जी और डेल्टा एच एक दूसरे के इक्वल होते हैं, फिर हम क्या करते हैं, डेल्टा एच में से यू शुड माइनस द टेम्परेचर एंड एंट्रोपी चेंज. Okay, so the temperature you should take up here, that should be in Kelvin, and the entropy you should take, that is kilojoule per Kelvin per mole. Okay, and the entropy you should change up here, that is kilojoule per mole. Okay, and the units of Gibbs free energy, that is also kilojoule per mole. Okay, so if you want to write down the definition of the Gibbs free energy, so what is that? The workable energy that reaches to us after increasing the temperature of system and increasing entropy of system is called Gibbs free energy. Everyone got this concept? Now, my dear, one more thing. If the Gibbs free energy value, Gibbs free energy, its value that is 0 or negative, so the reaction is feasible. It would take place at that particular temperature. But if the Gibbs free energy value that is positive, having the positive value, the reaction is not feasible at that temperature. But we can make it feasible by increasing or decreasing the temperature. Okay? So we could make it feasible by increasing or decreasing the temperature. So I want you people just listen to me, please, everybody, just listen to me. If the time would finish, I think we got the time remaining 6 minutes and 33 seconds. If the time is going to finish, the online student, please take a screenshot at the same spot. So I'm going to write down some points up here. Have a look up here. Delta G is equal to delta H minus T delta S. Okay? So the value of delta H is positive 40. Okay? So I want to check it at room temperature. Room temperature is 298 Kelvin. Okay? So 25 degrees Celsius or 298 Kelvin. Okay? So here we should write 298 Kelvin. And delta H value I am taking 0.03. Sorry, 0.03. Okay. Now please calculate it and let me know what the answer you got. That's the one. जी delta H मैंने ये ले लिया, ठीक है जी, और किस टेम्परेचर पे 298 केल्विन पे. बताइए जी, what the answer you got? G plus 31.06. So is this reaction feasible? No. It's not feasible because the positive value shows it's not feasible. So not feasible. Okay. Now what we are going to do? We are going to take the same equation, same values. Delta H is plus 40. I am going to write down up here plus 40 minus. Only I am going to change the temperature. Okay. So 0.03. So I am going to change the temperature to 2500 Kelvin. I am going to increase the temperature. So now what would happen? Please tell me what the answer is. Minus 35. So guys, now you could see the delta G value has become negative. So it means this reaction would become feasible. So in simple words, if a reaction is not feasible at a particular temperature, either you could increase or decrease the temperature, making the system to become zero or negative. Delta G is zero or negative. You want to make it zero or negative. Zero से visibility start है. Zero से negative visibility बढ़ती जाती है. Okay. So this is the end of this chapter. So tomorrow all of you are having a test.